Okay, so what we're going to be looking at now is the connection between a function and the derivative of all polynomial trig functions. So what we examined before is when the derivative is equal to 0, then that told us that the function has several possibilities. It has either a relative max, a relative min, or neither, which kind of seems weird, but don't forget that we could examine the cube function. Well, technically at x equals 0 of a cubed function, the derivative is equal to 0, and it's not a min or a max. So that's why we do have another option. But if the function, the derivative, is greater than 0, that means it's positive, then that tells us that the function is increasing. And then on the flip side, if the derivative is negative, then the function is decreasing. What about if the function changes from positive to negative? So if the derivative changes from positive to negative, then the function must change from increasing to decreasing. Well, what does that mean if we're changing from increasing to decreasing? Let me change colors. That must be a relative max. And then the same thing with the other one. Changes from negative to positive, the derivative does. Then the function must change from decreasing to increasing, which would be your include. That would be a relative min. I'm just going to double check the answer key real quick to make sure that we're good. Otherwise, you can pause the video to write this down. So I put in a little bit more information there than what the answer key does, but I think we're good. All right, so I'm going to scroll down again. Feel free to pause at any point. So what we have is a problem, and this is the same graph from a previous lesson. What we're looking at is we'll call this f over here, f of x. So if I'm asking you to find the possible graph of the derivative, what I look for is the maxes and mins, relative extrema. And I'm looking at the x values. That's at -3, right? Sorry, -4. So at x equals -4, my derivative, because that's what I'm graphing here, must cross the x-axis. And the same thing at x equals 1, because it's a relative min. My possible graph of the derivative must hit the x-axis, and then 1, 2, 3, 4, 5. My derivative must equal 0. And that's where previously I talked about the horizontal tangents of those. See how my tangent lines are all 0 there? Now to the left we have an increasing graph. Well, if we have an increasing graph, what does that mean for the derivative? That it's a positive. So it's above the x-axis. Now between -4 and 1, it's decreasing. Well, what does that mean for our graph? That it's below the x-axis. I don't care how far down you go, it's got to be somewhere below. And then from 1 to whatever this value is, 5, it's increasing, so it has to be above. I don't care how high you go, but it needs to be above. And then from 5 to infinity, it's going down. So decreasing means it's got to be a negative value. But let's be smart for a second. Let's look at what we have. If you look at this problem, from Algebra 2, you probably remember that, okay, well, we have an even function because our end behavior is the same, and it's going down, so it's got to be a negative. I'm just going to write a because I don't know what that value is. And it has 3 turning points, so that means it's a quartic. Now, it could be something else, and I don't even know anything else. But if I called this f of x, and then I asked you for the derivative, I hope you would all say, okay, well, bring the 4 in front, so it's negative 4 times that constant still, x to the third power, so on and so forth. But the point that I'm trying to make is that we have a negative leading coefficient with an odd degree. Does our graph match that? And the answer is yes. So keep your rules from Algebra 2. All the rules you've learned from previous units still apply in calculus. So more things that we could do in this problem is really emphasize we can look at graphs in different senses. I guess what I'm saying is like right here we're giving the graph of the derivative now, and then we can answer questions about the original function. So remember, if you're asked to approximate f prime of 4, you don't have to look only at x equals 4, which is like right here. What you can do is you can draw the secant line of points on either side. So I'm going to look at, I kind of regret writing on my graph now because it's really tough to see. But I'm going to look at these other values using x values on either side of 4. So 5 and 3. Now remember, the derivative, and we're approximating, is the slope. So what I'm doing is finding the slope of the secant line is what I'm really doing here, which is okay when you're approximating. All right, and then the y values looks like it goes up to 1, 2, 3, 4. And then this y value is -1. Now I'll connect those dots so you can see really what I'm doing. I'm approximating this slope by finding the secant line, and they should run pretty close to being parallel. You might be off a little bit, but that's okay because we're approximating. So you get 5/2, but what do you notice about that? Is it's a positive slope. So what does that mean? That at x equals 4, the function is increasing. F of x is increasing. Things like that. So now, at what values of f prime equal to 0, those are looking for your relative mins and maxes. So in this problem, at x equals -4, at 1, and 5. On what intervals is the derivative less than 0? Well, because they give you the function, you better say f of x is decreasing. So where is that happening? Well, between -4 and 1. Now, just a reminder, I like brackets, so I'm going to use brackets. And then from 5 to infinity, and a parenthesis with infinity. But there's my justification, that f of x is decreasing. What about where the derivative is positive? Well, my justification is if the derivative is positive, then the function needs to be increasing. So what am I looking at? Looking at -infinity to -4. And then from 1 to 5. Going up and to the right is where we're increasing. And what about the next one? What values of x does f prime go from being below the x-axis to above the x-axis? Well, if f prime is below the x-axis, that means it's going from decreasing, changes from decreasing to increasing. In other words, we're looking for a relative min, decreasing to increasing. So you can write out a relative min at x equals 1. And the same thing goes for the last one. At what x value does f prime go from being above to below? You could say the same thing, that f of x changes from increasing to decreasing. So that would be a relative max at x equals, there's two relative max, by the way. That would be at -4 and 5. Now, if anybody's sitting there and saying, well, why don't you give me the y values as well? Well, just because we know the function at f of x, we don't know well, I guess we could find the y values, but we don't have to because they only ask for the values of x, so we're good to stop right there. Sometimes what students will do is they'll actually graph the derivative on the graph as well. And I know this is the same problem we did before, so I'm just pointing out that you could have graphed the derivative on here as well. And we did this on the previous slide, so you don't have to. But sometimes students do that and they'll label right here and then answer the questions. So I just wanted to bring that to your attention. I think I can get this right problem done before I run out of time. And notice in this problem, this clears up if any of you are upset about how I'm using brackets, because now the directions say what open intervals. So that's telling the person taking the test to go ahead and write parentheses. And they typically write things like this if it's a multiple choice and they want to try and get students away from using brackets. And again, the calculus test does an amazing job of doing this. So since we're given the graph of the derivative and they're asking where f of x is increasing, we're only asking where f prime of x is greater than 0. So since this is the graph of the derivative, we want to see where this graph is above the x-axis, and that only happens right here. So on the open interval from -3 to -2. Again, they're only asking for the open interval here. So if I were doing this problem, what I would do is I would start, well, first of all, give the reason that f prime, if f of x is decreasing, f prime needs to be smaller than 0. Now what I would do is I would just say from -2, and it's below the x-axis this entire time until I get to x equals 4. And if you're going to say, well, what about at x equals 2? Well, the reason why I would not put split this up is it's decreasing to the left of x equals 2 and it's decreasing to the right. So I would say it's decreasing throughout. It's sort of like what we mentioned before with that cubic function, that if you're going down and then you're going down again, then you might as well just say you're going down throughout. But I don't want that right there. That's my reasoning for that answer. What about a horizontal tangent? Well, if you have a horizontal tangent, that means your derivative is equal to 0. So in other words, we're on the x-axis. Let me put that on here. On the x-axis at 2 x values. That's at x equals -2 and x equals +2. And you can just write plus or minus 2. That's acceptable. What about having a relative max? Well, in order to have a relative max, then your derivative must change signs. And if it helps, draw a graph. Like your max goes up and then backs down. So it has to go from increasing to decreasing. So that's my clue that f prime must change from positive, and increasing is a positive slope, to a negative. So which of those x values change from a positive slope to a negative, and that's at x equals -2, went from above to below. So that's at x equals -2. Now the same thing goes for the next one, for relative min, except it has to change from a negative to a positive. Well, look at your graph. Does it ever change from a negative to a positive? No. So there are no relative mins in this graph. So what about answering about the normal line? Now remember, the normal line at x equals 4 is you want the slope at x equals 4, which is -2. So f prime of 4 equals -2, which means the normal line is perpendicular to that. So that slope of the perpendicular, I'm just going to write it this way because we don't really have a notation for the normal line, is +1/2. Now I need to finish the notes in the next video.